Have you ever wondered why heat waves are becoming more intense? We're seeing a global trend where heat waves are not only becoming more frequent but also more severe. This intensification poses significant risks to our health, ecosystems, and infrastructure. Understanding the factors contributing to this trend is crucial. One of the primary drivers is climate change, which is leading to rising global temperatures and an increase in the frequency and severity of extreme heat events. Alongside this, certain atmospheric conditions such as high-pressure systems can worsen heat wave conditions by trapping heat and preventing its dispersion. Furthermore, our cities are experiencing amplified heat waves due to the urban heat island effect. This phenomenon occurs when human activities and infrastructure result in higher temperatures compared to surrounding rural areas. Lastly, lack of rainfall plays a part. Drought conditions exacerbate heat waves by reducing moisture in the soil and air, leading to higher temperatures and prolonged heat wave events. But these aren't the only factors at play. Let's delve deeper into this complex issue. So, we've touched on climate change, atmospheric conditions, the urban heat island effect, and lack of rainfall. But what else is causing our heat waves to become more intense? Let's start with land surface changes. When we alter the landscape through deforestation or urbanization, we're changing how the surface absorbs and reflects heat, which can intensify heat waves. Think of it like swapping out your backyard grass for concrete, and how much hotter that concrete gets under the summer sun. Next, we have air pollution. Greenhouse gases and aerosols trap heat in our atmosphere, turning our planet into a bit of a pressure cooker. This not only ups the temperature, but also reduces visibility, which further increases the heat. Don't forget about natural climate variability. Phenomena like El Niño and La Niña can shake up our temperature patterns and contribute to more intense heat waves in certain regions. It's like Mother Nature's own thermostat going haywire. Shifts in weather patterns also play a significant role. Changes in things like the jet stream or atmospheric circulation can lead to extended periods of hot and dry conditions. It's the meteorological equivalent of a heat wave getting stuck on repeat. We also need to consider ocean temperatures. Warmer sea temperatures influence our atmospheric conditions, potentially intensifying heat waves in coastal regions. It's like the ocean is giving the atmosphere a warm, moist hug, and not in a good way. Arctic amplification is another factor. The Arctic is warming at a faster rate than the rest of the world, disrupting atmospheric circulation patterns. This could lead to more frequent and intense heat waves in mid-latitude regions. It's a chilling thought, isn't it? Finally, we have feedback from land surface changes. When we decrease vegetation cover or increase urbanization, we can create feedback loops that amplify heat wave intensity. It's like throwing fuel on an already roaring fire. As you can see, it's a complex combination of factors that's turning up the heat on our planet. Now that we've explored the myriad factors contributing to heat wave intensification, let's summarize what we've learned. Firstly, climate change is the primary driver of intensified heat waves, leading to rising global temperatures and increased frequency and severity of extreme heat events. Secondly, atmospheric conditions such as high-pressure systems can exacerbate heat wave conditions by trapping heat and preventing its dispersion. Thirdly, urban areas experience amplified heat waves due to the urban heat island effect, where human activities and infrastructure result in higher temperatures compared to surrounding rural areas. Fourthly, drought conditions exacerbate heat waves by reducing moisture in the soil and air, leading to higher temperatures and prolonged heat wave events. Fifthly, alterations in land use, such as deforestation and urbanization, can impact heat wave intensity by modifying the surface's ability to absorb and reflect heat. Next, air pollution, particularly from greenhouse gases and aerosols, can worsen heat waves by trapping heat in the atmosphere and reducing visibility, further increasing temperatures. Additionally, natural climate phenomena like El Niño and La Niña can influence temperature patterns and contribute to the intensification of heat waves in certain regions. Also, changes in weather patterns, such as alterations in the jet stream or atmospheric circulation, can lead to prolonged periods of hot and dry conditions, exacerbating heat waves. Warmer ocean temperatures influence atmospheric conditions, potentially intensifying heat waves in coastal regions through the transfer of heat and moisture. Lastly, rapid warming in the Arctic disrupts atmospheric circulation patterns, potentially leading to more frequent and intense heat waves in mid-latitude regions. In conclusion, the intensification of heat waves is a complex phenomenon influenced by multiple factors, including climate change, atmospheric conditions, land surface changes, and natural variability. By understanding these factors, we can work towards developing strategies to mitigate the impacts of heat waves and protect our vulnerable communities and ecosystems. Remember, knowledge is power, and with it, we can take steps to adapt and prepare for a warmer world.